Why do we sleep? Sleep helps restore our body and our mind. Memories are filed away or deleted, and stresses are dealt with. After a good night's sleep, we feel refreshed and energized.
Sleep is regulated by wakeful substances and sleepful substances. When someone is sleeping, they produce a wakeful substance, and awake, they produce a sleepful substance. We do this to cancel out the current surplus of what has been produced over the previous time. An example of a sleepful substance is adenosine. It builds up to cause drowsiness, and an example of a wakeful substance is norepinephrine. The ability to remain asleep or awake is called mutual inhibition and is a part of the circadian alerting signal. Extensive exposure to sleep or being awake for too long causes an increase in delta wave activity during the next sleep cycle.
If you want to think of it in a summary, basically there's an on switch and then there's an off switch. The hypothalamus is a really good place where sleep is controlled, wakefulness and alertness, and they're still working on it, but they're pretty much trying to hone it down to the hypothalamus. There's all parts of the brain that are involved in the neurotransmitters, the on and off switch, the balances. Oftentimes one will negate the functions of another as far as neurotransmitters, and then as the night wears on, one comes out of the system, and dopamine is one of the biggest neurotransmitters which is involved with sleep. So think of dopamine as the one that kind of gets less and less as the night wears, as the day goes on, and then you don't have enough, or vice versa. And so
There are many neurotransmitters that are involved in waking. The most important is acetylcholine, which acts almost like an on and off switch when you're sleeping. The next is norepinephrine, and this decreases EEG waves, which are the waves that your brain gives off when you're sleeping. And serotonin is third, followed by hypocretin, which promotes wakefulness in many different parts of the brain, and a lack of hypocretin causes narcolepsy. Waking up. There has to be a reason for waking up. It may be caused by a dog barking, a door slamming, the need to use the restroom, or in the case of sleep apnea, someone stops breathing. A person's stress is what keeps them awake.
There is a group of neurons in the brain which are in charge of putting someone to sleep or waking them up. The destruction of these neurons can result in no sleep, which eventually puts someone in a coma and leads to death. When these neurons are stimulated, though, someone quickly falls asleep, and the more someone is awake, the faster they're able to fall asleep, which is why after a long period of not sleeping, someone can easily fall asleep. When the neuron firing is imbalanced, one's sleep becomes unstable and they can become narcoleptic. When brain activity is low, neurons may fire for someone to sleep. This is why people get really drowsy during boring lectures. A chemical called adenosine stops these neurons from firing and allows someone to stay awake. Caffeine has adenosine in it, which is why a lot of people use that to stay awake. In older people, though, adenosine has little to no effect.
The rate of cerebral metabolism is as high during REM sleep as it is during awake, and physical activity would be high also if muscles did not become paralyzed during REM sleep. REM sleep is controlled by parts found in the pons. Neurons in the dorsal pons turn on certain components of REM sleep. There is evidence that the neurotransmitters serotonin and norepinephrine inhibit REM sleep.
There's dopamine, GABA, there's serotonin's involved. There's a whole lot of other things involved, and quite frankly, to kind of go back to the neurochemistries, it'd be tough because it's not just one thing; it's multiple things, and it's a fine-tuned machine. That's what we're at. Basically, we're a fine-tuned machine, and basically, it's a balance of one versus another. I think to kind of just hang your hat on one neurotransmitter would be a disservice to what really is going on when it comes to sleep. Once you figure out what helps with the REM sleep, a company can develop a pill. It says, we got this pill to help you get in some dreams. But oftentimes there are a lot of other pathologies that prevent you from getting to dream sleep. So it's not necessarily true that you don't have enough of this chemical. It's just that maybe something is preventing you from actually getting to dream sleep.
The pineal gland controls the seasonal rhythms that change when time changes 12 hours in the winter and the summer. Melatonin is secreted by the pineal gland and controls the rhythms in mammals and skin complexion in non-mammals. The suprachiasmatic nucleus works with the hypothalamus to release melatonin during sleep. This allows animals to change cycles when seasons change, and when the suprachiasmatic nucleus is damaged, it will disrupt the connection, disallowing the transfer of information, allowing these changes.
Melatonin. When it gets dark, the brain begins to produce melatonin. Television and computers give off light, which tricks the brain and postpones melatonin production.
Jet lag and biological clocks. The amount of days it takes to readjust your sleep patterns is equal to the time difference. This means that it would take someone traveling from California to New York 3 days to readjust their biological clock. Just remember, your biological clock will be true to you if you support it. Interesting facts. Your metabolic rate is very high during sleep. Narcolepsy is often misdiagnosed as schizophrenia. 1/3 of our lives are spent sleeping. Dreaming is a form of therapy.
Like, wave your arms around. Oh, wait, let's try it again, because I can't be waving my arms around.
Okay.
Go.
They do the... I bit myself.
Okay.